Some basic terminology of statistics. Okay, in order to start this class, we need to come to an agreement. We need to come to terms with a few terms in statistics. So this is a brief lecture on some basic terminology that we're going to use in statistics and why we're going to use those terms in a particular way. The first distinction that we need to make in data analysis and the topic of basic statistical methods is a distinction between variables and constants. So a variable is a measurement that changes from one observation to the next. A constant is a measurement that stays the same from one observation to the next. So in the physical sciences, many observations are of constants. Thus, a single careful measurement can tell you the whole story. In contrast, in psychology and behavioral sciences, there's very few constants, if any at all. So therefore, we're going to have to cope with variability and variables. Now, variability is the statistical term for the degree to which scores differ from one another. So let's consider a concrete example real quick. And that is, in the smoking study, there is a column that measures or that has scores for depression. And the code for that score was CESD. And what we have here is we have a capture of the spreadsheet with ID number over here. You can see these are random, or just numbers to protect the identity of the particular participants in the study. But these are just ID numbers. And then this is a score of depression. Now, some participants have scores of 0, others have 2 and 11 and 7 and 13 or 12 and 1. So these data are messy in the sense that the scores differ from one another. And the degree to which these scores differ from one another is the statistical term we use for that is variability. Now, I'm emphasizing the word degree because what we're actually going to do is measure the degree of difference. It's not just that they are different, it's how different are they. We're going to be able to, in a week or two, assign a number to describe the degree of difference between these. So variability is not only the fact that they are different. In statistics, we're going to be able to quantify that difference or assign a value that talks about or that describes the degree to which they differ. Now, it's easy to see that depression scores are different, but why are they different? Well, one of the sources of variability in these depression scores are what we refer to as individual differences. Some people are just more depressed than others. That's a source of variability. That's why scores, these depression scores are different from one another. Some people have difficulty reading and understanding the questions on the test, or maybe they didn't really understand the questions very well, and they didn't know exactly how to answer the question. They were a little confused, but they didn't want to disappoint the experimenter, and they were trying to do their best, but maybe they didn't understand the question exactly right. Some people answer the questions more honestly than others. Some people may try to figure out in an experiment what the scientist is trying to do and try to give them the answer that they think is correct. Or they might try to they might lie a little bit because they feel their condition is worse or better off than other people. So those are sources of variability that we refer to as individual differences. There also may be differences in the procedure, in the differences in the way data are collected. In large studies, often you have multiple people doing the same experiment, and how they ask the question or how they consider an answer, how they interpret an answer might affect scores and might change one. So somebody might say, ask a question, on a scale of 1 to 10, how do you feel about this? And a person would say, I don't know, I feel like, 6.5 or something. And one of the experimenters might say, well, we only take whole numbers, so I'll give you a 7. Whereas another experimenter might say, okay, 6. That can be a source of variability. So, and there are other ways in which the data collection procedures can have variability intrinsic at them. There's also maybe, this is somewhat argumentative, there may be randomness in the world, or there are things that we don't know that provide variability, that are sources of variability. The world's an imperfect place, right? There's chaos, but there's also ignorance. We don't know all of the variables that might affect a particular score. We're learning more and more and more, although there might be at its core some randomness, some chance to the universe. And the last source of variability, or major category of sources of variability, are the conditions or treatments. These are the conditions that the participants of the study are exposed to. These can come from us as experimenters or researchers. We can give one group one drug and give other group placebo, and that might change the scores. That might induce or change or increase the variability in the scores. Or it may be, if we're doing an observational study, it might be, dog owners versus cat owners. Let's say those aren't conditions that we imposed on them, but they're conditions in which we sort of view our participants. So the major sources of variability can be categorized in these groups: individual differences, the procedure, randomness, or conditions of treatments. So, why all this talk of variability? Well, because of variability, we'll have to do more than a single careful observation to learn about the world. If we're measuring a constant, as I said earlier, and I said it before, and we wrote in the book, a single careful observation will provide you with the answer. If you're measuring a constant, that's all you need to do. You only need to do it once, because it shouldn't change from observation to observation. That's the definition of a constant. Since we're not measuring constants in the behavioral sciences and psychology, we're going to have to take many measurements. We're going to have to do many observations. And these are going to help us figure out, these many observations, these many measurements that we take will help us figure out tendencies or odds or probabilities or likelihoods or chances, those sorts of things. But as a little caveat, I just want you to recognize that this won't tell us what's true, but what is most likely true. So, when we're taking many measurements, another terminology difference or distinction that we need to make is between populations and samples. And that is, when we take a group of measurements, a set of data, we're going to refer to it as either a population or a sample. Now, a population is a collection or a set of measurements of a variable that shares some common characteristic. I like to think of this as all of the scores. It's everything. It's all of the scores that we can possibly take. A sample is a subset of measurements from a population. And a special type of sample is called a random sample. Now, the size of the data set does not distinguish or does not tell us whether it's a population or a sample. Populations can be very small. Populations can be very large. Samples can be very small. Samples can be very large. It's not the size of this set of data that determines whether it's a population or sample. It's whether you have all of them or not. And when I say all of them, that's when we refer to all of the scores that share a common characteristic. So, for example, the population of people, let's say, with Alexander's disease in the world is very small. It's like 30 people, but that is a population. Is all of the measurements could be 30 people. If we wanted to measure all of the California condors, those big birds that live in California, there's only a few of them. It's not a huge population. We could also take a sample of people with Alexander's disease or a sample of California condors. But whether a data set is a sample or a population is not determined by its size. if we wanted to do a large study on, if we wanted to do a study on a drug and its effectiveness on people with heart disease, we couldn't possibly measure every person or give every person with heart disease this drug because there are millions of people with heart disease. So we're going to have to take a sample of people with heart disease and give them this drug. Okay? Now, a random sample, as I said, is a really special sample because when we take samples, we want to make sure that they are random samples, or at least representative samples, non-biased samples. A random sample is obtained through a process called random sampling, where every observation has an equal chance of being included in the sample. That's the basic definition of a random sample. I want to include one more part, and that is that one observation, that a particular observation does not affect the chance of another being included. Okay, so this little is a second little caveat that I want to throw in there in a random sample, because sometimes what researchers will do will say, well, I'm taking a sample of people from the world, and boy, I got a lot of men, so I'm not gonna use any more men in my study. Well, that doesn't work. That's not a random sample. If you start to exclude people because they don't fill a certain requirement in your sampling process or something like that, that's not a random sample. This leads us to a third distinction that we need to talk about, and that is the types of statistics that we're going to study and talk about this semester. The first is, and this corresponds with the first unit that we're going to be working through, is descriptive statistics. And these are procedures or methods used to organize and summarize the measurements and samples in populations. So the goal of descriptive statistics is to summarize and describe. We want to go further than that, though, right? We want to be able to determine likelihoods and chances and tendencies and so on. We don't want to just be able to draw a conclusion about our sample. If it's a random sample and a representative sample, we don't want to say just our sample of people with heart disease is positively affected by this drug. We want to be able to conclude or draw the conclusion that maybe all people would be affected beneficially by this drug. And that's the goal of inferential statistics. And those are procedures we use to make educated guesses about populations based on random samples. We're going to draw inferences. We're going to go beyond our data set and be able to draw a conclusion about the likelihood or the chance or the probability of something. So when we talk about sets of data, we're going to be talking about populations, the complete set of data about which we want to summarize. And the quantitative characteristic of a population is called a parameter. We're going to distinguish that from a sample, which is part of a population. And technically speaking, the quantitative characteristics of a sample are called statistics. So we're going to be talking about populations and parameters and samples and statistics. And if you want a little mnemonic, PPSS, population, parameter, sample, statistic. Now, I've been talking a lot about observations. Again, in terms of the goal of this lecture was to talk about basic terminology. When conducting research, measuring variables attributed to a participant is called an observation. That's what we do. We go and measure something, and when we take a measurement, we call that an observation. The number of observations in research is designated usually in an experiment or in a study with the letter N, big N or little n. It's the number of subjects or the number of observations. You'll often hear a statement something like, what was the N of a study? Now, it's not necessarily the number of variables that you measure, but it's the number of observations or the number of participants. Okay, so hopefully that gives you a little background on basic terminology. We'll see you soon.